welcome to our channel Genius Public Inter College. I am Abhishek Tripathi and I will teach you physics. Today we are starting with physics of class 10th, chapter number 10, which is light, reflection and refraction. In this chapter we will learn about various functions and properties of light, how to form an image of an object by using ray diagram, some spherical mirrors, types of spherical mirrors, then mirror formula, linear magnification, etc. So without wasting our time, let us start today's class. Then students, first question arises in your mind that what is light? So students, light is a form of energy. Light is a form of energy which enables us to see different objects, because light is electromagnetic in nature. Therefore it does not require any medium to travel from one place to another place. Means light does not need any medium. As you see, light comes from the sun, travel in space where there is no medium. After understanding the definition of light, our next question, how the light works. Light has a property of reflection. The returning back of light ray in a same medium after striking with a bright and shiny surface. If a surface is a bright and shiny, then the light reflects back in the same medium. This phenomena of light is known as reflection of light. Very first point is, what is surface and how many types of surfaces? The light reflects on two types of surfaces. First one surface is regular surface and second surface is irregular surface. If the parallel incident rays gets parallel after reflection from a surface, then it is known as regular surface or a smooth surface, and a surface after striking on which light becomes zigzag form, then the surface is known as irregular surface. Then next one is laws of reflection. Before studying the laws of reflection, let's recall some important points on reflection. The light which incident on a surface is known as incident ray. The light which reflects back on a same medium is called reflected ray. And the normal means the perpendicular ray at the point of incidence means O is known as normal ray. Therefore, the first law of reflection is that the incident ray, reflected ray and normal ray lie on a same plane. As you see that these all three rays, which is incident ray, reflected ray, normal ray, on a same plane. There is no other plane required to draw these three rays. Therefore, first law is that the incident ray, normal ray and reflected ray lie on a same plane. The second point means second law is that the angle of incident and the angle of reflection should be equal, always equal. And what is angle of incidence? The angle between incident ray and normal ray is called angle of incidence, and the angle between normal and reflected ray is known as angle of reflection, denoted by I and R respectively. So there are two types of laws, which are the incident ray, normal ray and reflected ray lie on a same plane, and the angle of incidence and the angle of reflection is always equal. Next, move on the next topic, which is spherical mirrors. What is a spherical mirror? Suppose we have a sphere which is made up of glass. If we cut it by a plane, then what shape you get? You get this shape, this. This type of shape you get. These mirrors are prepared by cutting a hollow glass ball. As I am saying that these mirrors are prepared by cutting a hollow glass ball. The glass cut piece has two surfaces. The cut glass piece have two surfaces, that is outer surface and inner surface. Here it is known as inner surface and this is known as outer surface. In the same way, this surface is known as outer surface and this surface is known as inner surface. This shape you get after cutting the spherical ball by a plane. This surface is known as inner surface and this surface is known as outer surface. Now, if we paint by a red oxide either one of these two surfaces, if we paint inner surface, then outer surface is called reflecting surface. It means light gets reflected by this surface. And if we paint outer surface, then the inner surface of a spherical mirror is become a reflecting surface. Here the inner surface is painted by red oxide and outer surface becomes reflecting surface. In this type of mirror, here outer surface is painted by red oxide and inner surface becomes reflecting surface. The basis of these two painted sides mirrors are two types. First one is concave mirror and second one is convex mirror. If inner side is reflecting surface, then it is concave mirror, and if outer side is a reflecting surface, then it is known as convex mirror. Now let's move on the next topic, which is terms related to mirrors. As we know that mirror is a part of hollow sphere made up of glass. So the glass sphere from which mirror is cutted out, there is a center. The center of a hollow sphere from which a spherical mirror is cutted out is known as center of curvature of the mirror. Same here also. The center of a spherical ball made up of glass from which a spherical mirror is cutted out is known as center of curvature of that mirror. And the midpoint of spherical mirror, is called pole. Here also the midpoint of spherical mirror is called pole. Now if we draw a line which is passing through a pole and center of curvature, if we draw a line which is passing through the pole and center of curvature, then it is known as principal axis. Here also, if we draw a line which is passing through the pole and center of curvature, then it is known as principal axis. Note it that principal axis is always perpendicular to the pole. Principal axis is always perpendicular to the pole. Now next point, what is radius of curvature? As you see that this radius of a spherical ball made up of glass is known as radius of curvature of a spherical mirror. Here also radius of curvature of a spherical mirror is the radius of hollow sphere. Next one is focus. What is focus? What is focus? Now the midpoint of pole and center of curvature is called focus. The midpoint of center of curvature and pole is called focus of the spherical mirror. Here focus of the spherical mirror. The length between focus and pole is called focal length, denoted by small f. The length between focus and pole is known as focal length, denoted by small f. It means that there is a relation between focal length and radius of curvature, because radius of curvature is a distance between center of curvature and pole, and focus is the midpoint of center of curvature and pole. Therefore, we can say that f is equals to r by 2. It means focal length is half of radius of curvature of the mirror. Now move to the next topic. Next topic is rules of image formation by a spherical mirror. If we draw a ray diagram of a spherical mirror, image formation by spherical mirror, then we have to follow some rules. First rule is a ray which is parallel to principal axis will pass through focus after reflection. It means if a light ray which is passing through which is parallel to the principal axis, if a light ray parallel to the principal axis, then after reflection from a concave mirror, it passes to the focus. And in case of convex mirror, if a light ray is parallel to the principal axis, then it appears to come from focus. Here you can see that it appears to come from focus, because in convex mirror you can note that in convex mirror focus and center of curvature are virtual, not real. But in case of concave mirror, the focus and center of curvature are real, it is not virtual. So you can say that in case of convex mirror, if a ray is parallel to the principal axis, then it appears to come from focus. The second rule is that if a light ray is passing through the focus, then it will parallel to the principal axis after reflection. In both cases, in concave mirror, if a light ray is passing to the focus, then it becomes parallel to the principal axis. In this case, in the case of convex mirror, if a light ray appears to come towards focus, then it becomes parallel to the principal axis. Next rule is ray incident at pole is reflected back, making same angle with principal axis. If a ray of light is incident at the pole, then it reflects back, making at the same angle. It means this angle and this angle are the same. Same here, if a light ray is incident at the pole of the mirror, then it reflects back on the same angle as it is incident, and reflection angle are same by the law of reflection. So these are the three rules which we can follow to draw a ray diagram of image formation by spherical mirrors. These three rules can be followed. Next topic is image formation by concave mirror. Means how many types of images can be formed by concave mirror. What are the conditions to form an image of a spherical mirror? Let us see. These are the types of images. Let us see how these images can be formed. Images can be formed by using the rules of image formation by a spherical mirror. So students, let's see how these images can be formed using ray diagram. So first point is when object is placed at infinity. When object is placed at infinity, then image can be formed such as the rays which come from infinity can be parallel to the principal axis like this, and may not parallel to the principal axis like this. If these lines are parallel to the principal axis, if the light rays are parallel to the principal axis, then after reflection it passes to the focus. The point of intersection of reflected rays, these two reflected rays are meet at a focus. Therefore, the image of an object which is placed at infinity is formed at focus, and the size of image is very small, like that point size image. Therefore, we can say that the object which is placed at infinity formed an image at focus and whose size is point size. And if the light rays are not parallel to the principal axis, then the reflected rays are incident just below the principal focus. It means the image is formed at focus also in this case. Therefore, we can say that formed at principal focus, size of image is very small, which is point size. Let us Let us see next point, which is the image is real and inverted. Let us come on the second point, second case, which is when object is placed at beyond C. Means when object is very close to the mirror. Let an object which is placed beyond C, the rays incident on mirror, there are many rays. There are many rays which are incident at the mirror, but we have taken only two rays. For the image formation, here we follow the first rule, which is if light rays are parallel to the principal axis, then it passes to the focus. And another rule, if a light ray is passing to the focus, then it becomes parallel to the principal axis. See these two reflected rays, first reflected ray and this one is second reflected ray. The intersecting point is here. In intersecting point, the image is formed at intersecting point. You can see that the image is formed between focus and center of curvature. Therefore, we can say that image is formed between center and focus, center of curvature and focus, real and inverted. As you say that the size of image is smaller than the size of object. Let us move on the third point, which is when object is placed at C. If we take this object as much as near to the mirror, the object is placed at center of curvature. There are thousands of rays which are incident on the mirror, but we have to take only two rays. First one is which is parallel to the principal axis. Let us take first ray which is parallel to the principal axis. It passes to the focus, and by applying the second rule, if a light ray is passing to the focus, then it becomes parallel to the principal axis. As you see that these rays are incident, these reflected rays are incident just below the center of curvature. It means image is formed at center of curvature, and as you see that the image is just below, therefore real and inverted, and the size of image is same as the size of object. Therefore, we can say that our image is formed at C, which is center of curvature. Size of image is same as size of object, and real and inverted. Let us move on the fourth point. If we place the object between C and F, there are many lines which are incident on a mirror, but we have to take only two incident rays. First one which is parallel to the principal axis, then after reflection it passes to the focus. And the second rule, if we take a ray which is passing to the focus, it becomes parallel to the principal axis. As you see that the image is formed at beyond C. Here image can be formed. So we can say that image is formed beyond the center of curvature. Size of image is larger than size of object, and the image is real and inverted. Let's move on the fifth point. Fifth case, when object is placed at focus. If we place an object at focus, then where the image is formed. Here also thousands of rays are incident at the mirror, but we have to take only two. First one which is passing through the center of curvature. Here a line which is incident at this, after reflection it passes through the center of curvature. As we know that the line which is passing through the center of curvature does not deflect its path, means it reverses on the same path. And the second ray which is passing through the pole, making the same angle, reflect in the same medium. Since these lines does not meet anywhere, therefore we can say that the image is formed at infinity. So image is formed at infinity. Size is very large, means enlarged. You can say that enlarged. real and inverted. Okay? Okay students, now next point is, if when an object is placed between P and F, if we put an object between P and F, then what happened? Let us see. There are thousands of rays incident at the mirror, but we have to take only two. First one, which is passing through the center of curvature, it reflects on the same path, means it reflects on its same path. It reflects on the same path. And the second one is passing through the pole, incident on the pole. It reflects on the same angle. As you see that these two lines never intersect each other. But if we produced forward direction, if we produced it in forward direction, then it meet virtually but not really. It forms an image behind the mirror. It forms an image behind the mirror whose size is larger than the size of object. Therefore, we can say that the image is formed behind the mirror. Size of image is larger than the size of object, and the image is virtual and erect. Okay? So these are the 6 type of images. We have learned how these images can be formed by using ray diagram. Now let us take how an image is formed in case of convex mirror. In convex mirror, if we take an object front of the mirror, then there are 2 rays which is parallel to the principal axis. It appears to come from focus after reflection, as you see that, and the second ray which is passing to the center of curvature, here these 2 reflected rays never intersect each other, but behind the mirror they intersect virtually at point between P and F. Therefore, we can say that the image formed by convex mirror is always virtual, is smaller in size than object. Clear? So, let us move on the next topic, which is mirror formula and magnification. Mirror formula is used to solve various numerical problems based on this mirrors, types of mirrors, images, objects. And magnification. What is magnification? Magnification is the ratio of height of image to the height of object. Mirror formula is 1 by f is equals to 1 by v plus 1 by u. Here, what is f? F is known as focal length. F is known as focal length of the mirror. U is the distance of objects from the mirror. As you see that, U is the distance of an object from the mirror and V is distance of image from the mirror. In both cases, convex and concave. The magnification of the mirror is height of image to the height of object. Since we know that the distance of image from the mirror is denoted by V and the distance of object from the mirror is denoted by U. Therefore, we can say that M is equals to M minus V upon U, or you can write it as I upon O. I means height of object and O means I means height of image and O means height of object. Next one is sign convention. Sign convention is very useful to solve various numerical problems based on mirror formula. We have to use these rules to solve the numerical problems. So there are 4 basic points for sign convention of mirror. 4 basic points. First one is the object is always placed on the left side of the mirror. It means object is always, if this is a reflecting surface, this surface is reflecting surface, object is always placed on the left side. Object, this blue line denotes the object. Object is always placed on the left side. First point. Second point is that all distances are measured from pole. which is distance of object, distance of image, focal length, radius of curvature, all distances are measured from pole. You can say that pole is the origin of mirror. Now move to the third point. Third point says that the distances right side of the mirror, the distances right side of the mirror taken as positive and the distances left side on the mirror taken as negative. Fourth point, the distances, the heights which are above the principal axis taken as positive and the heights below the principal axis taken as negative. So students, there are the 4 points, 4 important points based on the sign convention. First one is the object is always placed on the left side. Second one, all distances are measured from pole. Third one, the distances right side of the mirror taken as positive and the distances left side on the mirror taken as negative. Last one, fourth point, the height above the principal axis taken as positive and the height which is below the principal axis taken as negative. Okay students, now move to the next topic. Next topic is differences between concave and convex mirror. This is our last topic of the reflection part. So there are the 5 differences between convex mirror and concave mirror. First one is the difference of definition. Convex mirror is a spherical mirror whose reflecting surface is away from the center of a sphere of which the mirror is a part. Next one, concave mirror. Concave mirror is a spherical mirror whose reflecting surface is towards the center of a sphere of which the mirror is part. The second difference between convex mirror and concave mirror is the focus lies behind the mirror. In this case, focus lies behind the mirror, and in this case the focus lies in front of the mirror. You can see that here the reflecting surface is this and the focus in front of reflecting surface in case of concave mirror, and in case of convex mirror the focus is behind the reflecting surface of the mirror. Next point is convex mirror is also known as a diverging mirror. Convex mirror is also known as diverging mirror and concave mirror is known as converging mirror. Why? Because as you see that the ray which is parallel to the principal axis is diverged after the reflection from convex mirror, but in case of concave mirror you can see that the light which is parallel to the principal axis converged at a single point. This ray is converged, these two rays are converged at a single point which is at F. So we can say that the convex mirror is known as diverging mirror and the concave mirror is known as converging mirror. The fourth difference is the shape. This is the shape of convex mirror. Convex mirror look like this and concave mirror look like this. This is the fourth difference. Important differences between convex mirror and concave mirror. That's it from today. Thank you so much.